Use the data in the following table, which lists drive-through order accuracy at popular fast food chains. Assume that orders are randomly selected from those included in the table. Before we look at our question, we always want to add the total in the columns and the total in the rows, and then find the entire total. So when we add up for restaurant A, 337 plus 36, we get 373. When we add up the column for restaurant B, 274 plus 56 is 330. The total for C, 233 plus 32 is 265. Total for D, 130 plus 15 is 145. Now we want to add the total row for the order accurate. So when we add up all of these numbers, let's put that back, we end up getting 974. When we add up the total row for order not accurate, we get the following, 139. Now, when you add the total column here or the total down here row, it's going to give us the total amount for the entire restaurant. So that means we get 1,113. Now the question says, if one order is selected, find the probability of getting an order that is not accurate or is from restaurant C. Are the events of selecting an order that is not accurate and selecting an order from restaurant C disjoint events? So the first thing is, let's take a look. If we look at restaurant C, the total is 265. Okay. We also know that the total for the order not accurate is 139, and we know the entire total is 1,113. Okay. So to find the probability of A or B, we need to add the number of ways event A can occur and the number of ways event B can occur, but add in such a way that every outcome is counted only once. So the probability of A or B is equal to that sum divided by the total number of outcomes in the sample space. Now here's the formal addition rule. We have the probability of A or B, which is equal to the probability of A plus the probability of B minus the probability of event A and B. Meaning, where do they intersect? Because we don't want to count something twice. Okay? So we know that the probability of A and B denotes the probability that A and B both occur at the same time as an outcome in the trial of a procedure. Now, there were 139 total orders that are not accurate. So that's what we have in green there. So the probability that the orders are not accurate is total of not accurate over the total, which is 139 over 1,113. So now there were 265 total orders from restaurant C. So therefore, we would say that the probability of event B is the total amount of restaurant C orders, which is 265, divided by 1,113. Okay, now notice that there is an overlap between orders that are from restaurant C and orders that are not accurate, which is the following value. It's 32. But let's take a look up here. You can see that we count it once with the column, we count it again with the row, so we can't count it twice. So therefore, the probability of A and B is the overlap from restaurant C and not accurate, which is 32 over 1,113. Now, we want to find the probability of A or B, which is equal to the probability of A plus the probability of B minus the probability of A and B, since we found all three of those fractions. So that means we're going to say 139 over 1,113 plus 265 over 1,113 minus 32 over 1,113. And therefore, if we add like terms in the numerator, 139 plus 265 minus 32 is 372, divided by 1,113, which gives us this value here, and we're rounding it to 3 decimal places, which gives us 0.334. And therefore, the probability of getting an order that is not accurate or is from restaurant C is 0.334. Now, for two events, and this is talking about the last question here, which is saying, are the events of selecting an order that is not accurate and selecting an order from restaurant C disjoint events? Now, for two events, which is not accurate and selecting an order from restaurant C to be disjoint, only if the probability of A and B is equal to 0. Well, we found that the probability of A and B was equal to 32 over 1,113, which gives us an approximation probability of 0.029. Well, that doesn't equal 0, and therefore it's not disjoint. So we would say the events selecting an order that is not accurate and selecting an order from the restaurant C are not disjoint events.